This is not my first video on AI agents, and it's not going to be the last. The space of AI agents have been evolving drastically as LLMs continue to grow. And with the idea of multimodality, and for those of you who are not familiar with what that is, it translates to the idea of having LLMs the capability to work with images and videos. The ability to synthesize images and videos, process them, use them, consume them. So essentially, apart from the awesome text processing capability they have, we also want them to have the ability to handle and work images. And we have seen tons of work in that space: Flux, Midjourney, DALL-E, all of those previous models. And now things are getting into a single model as well. Like if you see GPT-4o, it's multimodal to an extent. Videos are still a little bit futuristic. You have a couple of attempts in that space. However, this paper, which came early this year, is a very, very interesting research into the whole world of agentic AI. And it's essentially surveying the horizons of multimodal interaction. So this is not a discussion on what has been done. It's a discussion of what's possible and some glimpse into that. Now, there are words which might seem a little far-fetched, and I feel the same way. Some of these definitely appear a little far-fetched, but I'm not going to fret over that fact for right now. So this image, basically, the idea is that an AI agent is a system which can perceive and act in different domains and application, essentially a software product or an entity which can perform tasks or multiple tasks or work independently. And it is emerging as a promising avenue towards AGI. Again, I don't know how much of that is true or how much of that is, just thought in this space right now. But there has been capabilities, there have been discussions where you have seen AI agents work multimodal. And I believe that people are relating multimodal to AGI, which probably is not true. But again, that's just my thinking. So this paper, again, I don't want to bring my own inherent bias into this, but essentially talk about this paper as to how all of this is evolving. So on the x-axis side, there's all of these different skills like task planning, skill observation, environment perception, cognition, learning, memory, working with feedback. And then z-axis is the agent paradigm. Y-axis is mostly how much is theory, how much is data, infrastructure, and applied. And on top, you have the physical world, virtual world, agent paradigm, embodiment, product. Now, products are very, very straightforward. You can have generative AI in gaming. I'll probably want to zoom this a little more. Generative AI in gaming, we have had them, AI working in gaming systems for a quite long time, smart gaming engines, which you would continue to fight and it will continue to evolve. You have had bots for a long time if some of you are into gaming. Then we have co-pilots for health, mechanical, generative AI, etc., etc. Embodiment is mostly into physical space, like autonomous vehicles, putting AI in robotics and stuff. So from applied space of autonomous vehicle and manufacturing to theory of control, theory, mechanics, and all of that. And in between, you bridge it, HCI and task specific. Agent paradigms, wide variety. There are generalist, autonomous, assistive, task specific, couple of more. And then you have all of these different infrastructure capabilities, which is planning, reasoning, multi-agent planning, etc. Then you have the data, which is actions, perceptions, view of the world, environment, etc. And then underneath is all of the basis into thinking, which is reasoning, intuition, intelligence, cognition, consciousness, all of that. And finally, then moving forward towards the left-hand side, you have the virtual world and the physical world where AI sits. Now, the interesting part is you have agent paradigms impacting all of these spaces. Why is that? Because agents are not really performing a task. They can actually execute a variety of tasks and do the planning, execution, as well as be context aware of what is happening in different steps of the execution. And this is very powerful thinking. So that's what this whole paper is built on the idea on. I'll move forward, and there's a lot of it. I think this is an 80-pager research paper. It also highlights a couple of different sections like how do interactions work, different paradigms, how do AI agents learn, how do you categorize different agents, what are the different tasks you can get into, different modalities that you can have, and then how do you improve them, data sets and leaderboard, etc. Again, a very, very exhaustive survey paper came out early in the year. Might be a little, don't want to call it outdated, but बहुत जल्दी change होता है ये world. So It's been literally 6-7 months, and or actually more than that. This came early January. So something that came January, we are sitting in the December. It's like 9 months old. Quite a lot has happened in that space. They're still looking at GPT 4V, 4V for bleeding edge, etc., etc. But 4V is now old. I think the vision capabilities have been incorporated into 4.0, and if some of the capabilities are not there, they'll probably come up. I think now people are excited about the strawberry model. If you want to know what that is, I did a video sometime back, link somewhere above. There's a very interesting image that came here, and I want to continue to talk about it. Oh, where is it? Yes. So this is the same image and trying to actually show you how things could look like. So you have a physical world interaction where there's a scene with conference room complete with tables and all that, and DALL-E is able to generate it. You extend this idea to the extreme right, where you have a simulator, mixed reality, metaverse kind of a product, where you have DALL-E or the likes of DALL-E generating the whole workspace. People are sitting in their digital avatars hooked onto some sort of a VR or Apple lens, or that that costly goggles we have. I mean, though that technology is a little too costly for public access, but again, thinking few years forward, as I was saying, this could be a very possible reality. You could be able to change your virtual spaces, virtual workspaces. And then this image shows that how a certain knowledge agent can show different interactions within a I don't know, town or a city. You could be interacting across different communities, different pieces or different places of visit. So probably you're starting from your home and you are headed to a hospital. There can be an agent that notifies much early of the the scenario that you have, the condition that you have. If you're visiting some of more like wearables which are health tech and can do some early detection, they can notify that and call the right doctor and things like that. Then again, a lot of other areas of interaction like game engines, flight simulators and things like that. So there's a lot of cross reality mixture with multimodality that always comes up, and people have been traditionally excited about this space. And again, the whole agent part is going. Now, this paper has tried to address most of the concerns as well, which is great. Don't think I'll be able to get into all of the depths of it, but yeah, there are a little bit of sequence of images as to how something works. So for example, there's a task planning step, then there's a demonstration, then a robot execution. This is how you kind of teach a robot, and then you have more scenarios as to how an agent paradigm for multimodal agent generalist should behave. Most of these architectures are very similar. There needs to be all of these 5 elements that is listed out there. So there'll be the environment and perception around it, there'll be learning, there'll be memory, there'll be cognition, and there'll also be some communication spaces as to how these agents are communicating between themselves. Are they message passing? Is there a coordination agent? Is there a agent that is kind of enabling a competition, things like that. Multiple communication paradigms exist in the space. And then how these agents are capturing information, how these agents are learning from that environment essentially is also important, which is like feedback loops, etc. Feedback can come from multiple sources. It could be humans, could be agent interactions, could be based on responses and all of that. This image is an example of embodied agent, which is more like an interactive gaming agent. And there are lots of scenarios that this paper tries to get into, produce task empowerment, task planning, things like that. Again, very interesting process. Also, if you think agent in terms of your lifestyle and the things that you do, workflows, could be interesting. Like I was talking to a bunch of people yesterday, and a simple idea that based on the weather, can I be ordered chai and pakoda by an agent, which is basically saying if it's raining outside, go to Zomato or Swiggy and order me food if it's my time for an evening snack. I might not be interested in it because I get tea at home, but it might be a good idea to explore. All right. With that thought, I want to leave you guys with more ideas that can be built on top of agents. And if you're new to the space, keep learning, keep growing. Bye-bye.